Okay, mathematicians, we're going to be working on lesson 1.3, and this chapter is called Thinking with Mathematical Models. So it has a problem that involves both a truss and a set of stairs. So a truss is a very strong piece of usually steel or metal that holds up a roof or a bridge or something that's very heavy. And you're going to be using the information in this picture from this construction company to help you find some patterns in them and use your mathematical thinking to do that. Okay, this is a 7-foot long truss in your example because on the very bottom it is 7 rods long. And if you look after you've counted the 7, then you want to look to see how many rods it took altogether to make this 7-foot long truss, and the answer is 27. So down here in the table that you're going to later copy into your math notebook or use in your assignment, 7 and 27 are represented. The x-axis has a 7 and the y-axis has the 27. And it has some others done for you. So let me show you this 2-foot long truss would look like this. So I'm covering up what's not being used. It's 2 rods long, and then you would count all those parts to it, and they total 7. So your first job is to copy, complete the table, and then graph your information. You can graph your information in a couple different ways. I have put a blank page for you to use on any problem you want to, and I have set my problem up, which I'll show you again later, like this for this one, and I've labeled it up there. But you may also just do this in your notebook if you'd rather do that. So I'm going to talk about the notebook for a little bit. So what you can see here is I've copied the table that they have, and I've set it up. I've set up my graph because A1 says to make a graph of this information. So the way I made this graph is I used a ripped out piece of paper. A ruler is really handy, but if you don't have a ruler, you can use the blue lines on your paper, and then in this torn out piece of paper, I've also used the blue lines to help guide my vertical lines in my graph. And you can see they kind of line up there. So I made little marks, and then I used the edge of my paper as a straight edge to draw some very light lines so I could end up with a graph. So you can hand draw graphs using straight edges or a piece of paper to help you. I've labeled the lines with numbers, not the spaces, and I've put titles on all 3 parts. You need to do the same as well as plotting your points and connecting your points. Now remember, not everything is going to be linear. So when you're connecting your points, connect from point to point with a straight line if you can, and then eventually you'll see some patterns that may not be straight lines in this problem. Okay, question 2 wants to know the pattern or change that you're noticing, and question 3 is how this pattern is represented in a table and a graph. So I've set this up in here so all spread out so you can see the different questions very clearly. And my sentence system here is the longer the truss gets, and then I would go on to answer the question. I would like you to think about linear and nonlinear, or increase and decrease, or both. Use that terminology when you're answering questions in this part of the chapter. Then you find it in the table by looking here, and you find it in the graph by looking here. We talked about linear and nonlinear equations a lot on Friday. Use the language that we talked about on Friday and the patterns that we found together to help you answer these questions. Okay, question number 4 wants to know if you have a 50-foot long truss, so it would be 50 across the bottom, how would you be able to figure out how many rods to use, and how would you do that without drawing? So I've started my sentence here, and you would fill in the blanks, and then I want you to think about possibly talking about equations. We'll be figuring out equations for lines a lot in this chapter, or curves or other shapes. So if you can figure out some kind of equation, that's where I want you to go for number 4. In question number 5, this person in the story, her name's Jenna, she already has an equation that she's using, and after you read this part, it wants to know what each part of her equation means. So she's used in 3L, and she's used in L minus 1. So I want you to go back and look at the pictures. If you're kind of stuck on that one, think about how the triangles are formulated and what the minus might be when you are putting all those triangles together. So I've answered that question, or started that question anyway, by making sure I'm going to talk about each part and then continuing my sentence there. Notice if you're working your notebook, you're going to take more than one page likely to work on this problem. And what I would do is I would continue working in the same manner for the next problem, which is B. And this is where we're going to be looking at steps. So I would have my table, I would have my graph, and I would have all my questions answered, and it's probably going to take quite a few pages. When you're all finished, you would snap a photo of this and upload it. Okay, that is one way to do this assignment. The other way to do the assignment is to make a digital copy of this that you can write on and answer all your questions and do your graph on this. And the third way is to print this out and write on it. So I'm going to show you what that would look like. This is where I've used that piece of paper and actually physically written on it, although you could do it electronically. Question B, instead of making a truss system, you're going to be making a set of stairs. You're using the same rods, they're still a foot long, but instead you're making of triangles, you're going to be making these squares that build up on top of one another to make the stairs. It's giving you 3 examples here and plugged those examples into your table. The first thing it wants you to do is to finish the table and make a graph. So instead of drawing it, you, as I did in A, if you chose to, you could use this piece of paper, fill out the table. We only need part of the table, and then you could use the graph to help you. You may also cut and paste this onto electronically onto another page if you would like to do something fancy like that. On this, make sure that you label all 3 titles in your graph, and you would have your graph on here, and number your lines on each side as well. Okay, so number 1 is table, number 2 is graph, number 3 and 4 are just like before. What are the patterns of change? How do you know? By looking at the table. How do you know? By the graph you made. So number 3, as the steps increase, I noticed blah, blah, blah. What was the pattern you saw? How did you see this in the table? How do you see this on the graph? So once again, think back to Friday's conversation about linear and non-linear equations. Okay, that was question 3 and 4. Question 5 says if you had 12 steps, how many pieces would you use and how would you figure that out without drawing the whole thing? So once again, maybe think about equations to answer this. We're following the same ideas as we did for A to finish the questions for B. So this is a 12-step frame. This is how many it would use, and this is how you can find it without doing all the pictures for it. Okay, that is all of B, and the page continues, so I think you're going to have to continue scrolling down on yours. And on this page, it has questions C and D. C wants you to think about how the questions in A are similar to and different than the questions in B. So we're only talking about the truss system and the stair system. So this is how I set that question up. Notice if you print this page, you simply can use the back if you write neatly. I can keep my writing kind of straight, but you're also welcome to use a notebook page in addition to a printed page. And if you're doing it all electronically, you can type, so it's not a problem for keeping it neat and tidy. Question C. They are similar because of blank, and they are different because of blank. You can tell this in the table in this way, you can tell us in the graph this way, and that is what question C asks about tables and graphs. So once again, we're thinking about linear and nonlinear equations and how you have evidence of that in your graphs and in your tables. And the last question is comparing everything you did today with the truss system and the stair system to the bridges that you did online for the online bridge building simulations. So it wants to know how problems 1.1 and 1.2 that you did online are similar and different to what you are doing today in your textbook pages. So that is question D, and I set that up simply by saying that all these problems are the same in this way and they are different in this way. Once again, your easiest way to answer that is to be looking for patterns in the tables and graphs and to be talking about increase, decrease, linear and nonlinear equations. Okay. Please let me know if you have questions on this assignment. It is rather long. It's kind of 2 assignments all mixed together in one. Whatever way you choose to make it, whether you choose to do it in your notebook or you choose to do it on this piece of paper, either is fine. I showed you me doing the question A in my notebook and question B on a piece of paper. I only did that as an example. It's probably better for you if you pick one method and stick to it. So do it all electronically on this, or do it all handwritten in your notebook, or do it all printed with the pages. Pick one method, whichever one you prefer, and go ahead and finish it in that manner, please.